We're going to learn about solving logarithmic equations, which is actually quite different from solving exponential equations. So we're going to be using some properties we've already learned about. If you have not watched my video about expanding and condensing logarithms and using these two properties, I would highly advise watching that first before learning this. And also, if you haven't learned about converting from logarithm to exponential form and vice versa, you might want to watch that as well. So these are the three big properties we're going to bring in when we're solving logarithmic equations. You don't have to memorize these. These will be on your formula sheet. So how do we know when we're solving? Well, it'll have the word log and it'll also have an equal sign. It'll clearly say in the instructions that we're solving versus converting equation from logarithm to exponential form. So the first two are actually really doable. So all you have to do for the first couple is notice that they have the same base. Put a little b there. So they have the same base for both of these. And when you have two expressions that have the same base, it's very similar to when we were solving exponential equations. If you haven't watched that video, maybe watch that one as well. So if they have the same base, you can actually cross the base out and the word log, and then just set the other stuff equal to each other. So that'll look like this. Negative 5b equals 8 minus 4b over here. And then over here on this one, negative 3a minus 9 equals 5 minus a, and we can put an invisible one. So we're going back to Algebra 1a, solving multi-step equations, which hopefully should be review. We'll get the letters to one side, adding our 4b over, which gets us a negative 1b equals 8. Dividing by negative 1, and we get b equals negative 8. Over here, you have a few options. I like to move the letters to the left, but if you want to move to the right, you can. Add that 1a over, we'll have a negative 2a minus 9 equals 5. And to get a by itself, we'll add our 9 over, getting us negative 2a equals 14. Divide by negative 2, and a equals negative 7. Sometimes in these videos, I'll go a little fast over solving the equation part, but if you do need a more in-depth equation review, please let me know. And also we have some great resources at our school as well. So if the bases are the same, we can set the other remainder of the equations equal to each other. Over here, number 3 and 4 are both set equal to a number. So this is the next type of example we could encounter. We notice that both logarithms are the same base, but we can't set them equal because they're on the same side of the equation. So we have to use one of our properties down here. We'll notice that we have two logarithms, same base, and we have a plus sign in the middle. So the first step here is going to be to condense our problem so we can solve it. So it's kind of similar to last time. We have a B, an M, and an N. So this is similar to our video on expanding and condensing logs. So the first step when we have just a number on the right side is to condense our logarithm. So we'll write a little note about that as our first key thing. So when we condense, if we have addition, it becomes multiplication. So we have log base 3, and I'm going to drop down the 8 and the x plus 5 and keep my little 3 over there. So the first step is to condense the logarithm. The second step is a little bit tricky. So we are going to first go ahead and, since it's possible to multiply this, let's go ahead and multiply that out and distribute. So the distributive property probably isn't too bad. 8 times x is 8x, and 8 times 5 is 40. And then that equals to 3. So we're kind of at a point where there's not a whole lot we can do here to solve it. So we're going to use our little note down here of going from logarithm to exponential form. So I'm going to write our second step when it's equal to a number is to go into exponential form. So we're starting with something that's log A, B, C. And when we go into exponential form, we're going into A, C, B. So we're switching the C and the B around, and we're getting rid of the log, which is going to make this solvable. So first we'll write our 3 without our log. It's going to be bigger. Our C is 3 as well. And our B is this whole expression right here, 8x plus 40. Now, this is something we can solve. 3 to the third power is 3 times 3 times 3, which is 27 equals 8x plus 40. If we want to get 8x by itself, we'll go ahead and get rid of the lonely number. 27 minus 40 is negative 13 equals 8x. And then we know that 13 doesn't divide by 8, so we can just leave that negative 13 over 8 equals x. In my personal opinion, 3 and 4 are the trickiest. So if you wanted to write yourself a little additional note on your formula sheet for solving logarithmic equations, I would be just fine with that. So maybe you write step 1 is condensing the logarithm, and step 2 is transforming the expression into exponential form, which then allows us to get rid of the logarithm and really solve this thing. Let's try this one over here. So we again have addition, and we are going to set up, or we are going to condense our log so it's a little bit smaller. And then we'll be able to rewrite it in exponential form. We're going to stick with our base of 6, and we're going to drop down 3 and x plus 3 side by side, because addition becomes multiplication. Drop down our number. So we've completed this first step, we've condensed it. Our second step is to transform it. So we have A, B, and C. It's really tempting to put a B there since we've talked about that before, our B being our base, but we want to make sure we're using the appropriate formula ABC, ACB. So whenever you're trying to rewrite something in exponential form, it's ABC. We'll rewrite it without the log, so we'll do A to the C power, which is 1, equals B. And I could have distributed that earlier, but I'm going to go ahead and show you that you can distribute after as well. So we have 6 to the 1 equals 3x plus 9. In this case, this is slightly easier than this one because 6 to the 1 is just 6. Anything to the first power is itself. We're going to get x by itself, moving the 9 over. I always run out of space at this point, so we'll bring it over here. 6 minus 9 is negative 3 equals 3x. Divided by 3, and we have our negative 1. I truly believe that those two are the trickiest because those first two were just setting without the log those expressions equal to each other and solving, where here you have to do a little bit more work. Now, there may be problems that have a minus in the middle. On the practice sheet, we can look for one of those and do one of those together. But I also want you to note that when you're condensing a log, it's not always transforming it into multiplication. It may be transforming it into division if there's a minus sign there. Now, this bottom one here is a little bit different. You'll notice it's equal to another log. So let's do this one since it's slightly different. So for number 5, it looks like 6 is the same as 3 and 4, so that'll be good practice. But for number 5, we also have some condensing to do. So like I had said earlier, if you have a minus in the middle, it's really important to remember the logarithm rule that minus becomes division. So we'll go ahead and rewrite with our same base, log 4. And then we'll have our x plus 3, but this time it's over 5, since we know that log b with the m and n becomes m over n. And you can delete the parentheses there since the x plus 3 is on its own. So in this case, we have condensed our log. And now you might be looking at this one and notice that you have log base 4 on both sides of the equal sign. And now it is just like number 1 and 2. So since the logs are the same and they're on opposite sides of the equation, we can write x plus 3 over 5 equals 20 without the logs and solve for x. Since we have all of this is being divided, we're going to multiply first. And that's 100, 20 times 5. The 5 cancels out over here, leaving me with x plus 3. Take away the 3, and I have x is 97. So I guess if you get to a point where you've done your condensing and you have the log with the same base on both sides, you can go right to doing it like number 1. The reason 3 and 4 had a little bit more meat to them is you didn't have the logarithm on both sides. Let's look at number 6. And now that we've talked about what to do with subtraction, I think that should be good. Since we have addition, we're going to start with condensing again. We're going to keep our base. And since it's addition, we're doing multiplication, 9 times negative 3x. We notice we have a number on this side, so that means we're probably going to have to transform it into exponential form. Before I do that, let's go ahead and make this a negative 27x, so it's easier to solve. And then I can label it with my A, B, and C, and go into an ACB form, which is 7, 1, and B by itself, negative 27x. 7 to the 1 is just 7. And then divide by negative 27. You can leave that just like that since it doesn't divide. The negative can go on the bottom, or you can leave it kind of to the side. But that one had that extra step because it was equal to a number. So remember, if you have any additional notes that you need to write on your formula sheet to kind of remember the ones with the number, you have to do a little bit more work of rewriting in exponential form, please feel free to do that. And these are probably the most complicated the logarithms get. So just let me know if you have any questions, and I'm here to help.